All right, let's do our first example of taking a derivative using the difference quotient. So we'll take the derivative of f of x equals x squared. Remember, our derivative formula, or our difference quotient, is f of x plus h minus f of x all over h, and we're taking the limit of that as h goes to 0. What we want to remember to do is plug x plus h into the function and then x into the function as we build this difference quotient. So here's how it looks. F prime of x is equal to the limit as h goes to 0 of, now it's going to be x plus h quantity squared minus x squared all over h. And then we just have some algebra to deal with. So remember, we always want to write this limit statement because we're working not with a function but with the limit of a function until the time that we evaluate that limit. So I'll just expand that binomial. It's x squared plus 2hx plus h squared, and then subtract the x squared. You can see those x squareds cancel, and so we can write a simpler limit. And now every term in this limit is going to have an h in it, and that's going to allow us to get rid of that h in the bottom. So I'll just factor this numerator so you can see this a little more clearly. We have h times 2 plus h squared in the top and h in the bottom, and now those h's cancel. And so now we're in a position to just substitute 0 directly in for h. It's not in the denominator to mess us up anymore. So we have the limit as h goes to 0 of 2x plus h, which is just 2x. So the derivative, or the slope function, of f of x equals x squared is just 2x. Okay, so now let's draw some graphs and see if we can make some sense out of that. So our first graph is just going to be of the function x squared, and of course that's just a parabola centered at 0, 0. And let's take a look and see what the slope of this graph does. On the right side of the y-axis, the slope is always positive and it's increasing. And on the left side, the slope is always negative, and you can either look at it as though it's decreasing as the function goes to 0, or that it's increasing in the negative direction as x goes to minus infinity, one way or the other. Now, if we draw the derivative, and I always want to draw that on a different set of axes because it really has different coordinates, that's just a straight line, y equals 2x, or y prime equals 2x. And you can see that this function accurately describes what the slope of x squared does. The slope is positive on the right of the y-axis, and it's always increasing. And the slope is negative on the left of the y-axis, and it's always getting steeper in that direction. And in fact, the derivative, or the slope, goes through 0 at 0, 0. Which reflects the slope of the parabola at that point.